Hello, students, coming to you live from Tornado Alley. Whoa, it's a spinner. It's a spinner. Today, you are going to watch us, my lovely assistant Isabella, bend down so we can see you, so the crowd can see you. Yay, Isabella! And so she's going to help me do this experiment that you could easily do this at home. It'll be great. And you can see the action of a tornado. It is on page 77. All the directions are there. Make sure you ask a parent before you go for it. And this is what we did, as directions have said. Come on over here, assistant. And I will put it up a little bit so her head's not cut off. Okay. So what you do, according to the directions, is you get an empty bottle, which who doesn't have an empty bottle laying around like a water bottle? We just happen to have a pop bottle, want to show us. And as it says in the directions, you want to fill it 3/4 of the way. So if you were to break this up into 4 pieces, then you fill it 3 of those pieces and leave 1 part there. Then, as it states, you put a few drops of dish soap in there and then some glitter if you want to, so you can see the action of the tornado. And then put the top on real tight. Yeah, you got to make the face when you do it real tight, just like Bella just did. You got to really screw it on and put it real tight. Then, handy assistant, show us tornado. You flip it upside down. It says to hold it by the neck, and you twirl it, twirl it, twirl it, twirl it, twirl it.
I'm not good at this.
All right, they say to swirl it in a circle motion, circle motion, circle motion. And it says you probably won't be able to do it correctly right away, but maybe you will. We'll see. Okay, let's see, handy assistant. All right, so you can see through it a little bit. There's a lot of glitter. We kind of went crazy on the glitter because I like glitter. All right, so you can see particles floating around. That would be like pieces of your home if it was a hurricane or tornado, and it was lifting off the ground, and then they settle back down to the ground when it has passed. So the glitter could represent that. Now, handy assistant, can you hold the light while I twist this, please? Can you hold the light? All right, I'm going to try it this time. Hold it upside down. Give it a swirl, 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 swirl. And I think we have too much glitter, but you can see, I just kind of saw it, a tornado action on the inside. This is an oldie experiment, but a goodie. And you just have to keep twirling and twirling and twirling in a circle and twirling. I kind of made like a tornado there, or like a storm. But before I added the glitter, I could do it. So you can kind of see the particles are falling again, and it should look like a tornado on the inside. So you can keep practicing and practicing and practicing to see if you can get it. And I'm going to practice one more time. Oh, I could see it way up top. I could see it way up top. Okay. So have fun with that, making tornadoes, and remember to ask a parent first and make sure the top is on real tight. Okay. What a storm, what a storm. All right, so, and then besides that, thank you, handy assistant, yay, yay, yay. Besides that, you are going to be reading with me the page before this experiment, which is page 75, extreme weather, extreme weather. So let's read that page together. I'll give you a second to find it, or pause the video. All right. Put that back down here a little bit. All right, extreme weathers. What is extreme weather? How is it different from regular weather? We know that weather is the condition of the air or atmosphere on our planet. An extreme weather event is something that falls outside the realm of normal weather patterns. Weather is considered extreme when it puts people, animals, or buildings at severe risk. So that's why it's extreme. Second paragraph. During warmer seasons, water in the ocean evaporates more rapidly, which can cause a severe weather phenomenon known as a tropical storm. Tropical storms happen when pressure from the evaporating oceans is paired with cool air from the atmosphere. This causes clouds to circulate and rise from the sea into the atmosphere, creating a spiral motion of wind. These destructive winds then move towards the land and can cause severe effects to the land's buildings, animals, and humans. So as we said before, if this was the wind and the glitter was things flying around your house, we used Christmas colors. But anyway, so things could fly right off your porch. I'm sure you've seen pretty bad wind before that just flew stuff off your porch. All right. So those things can happen. Third paragraph. There are 3 types of tropical storms: a hurricane, a typhoon, and a cyclone. Hurricanes, cyclones, and typhoons are all the same weather phenomenon. Scientists just call these storms different names depending on where they originated. Hurricanes begin in the Atlantic Ocean. Typhoons begin in the Pacific Ocean, and cyclones come from the Indian Ocean. You can find those on a map. That would be awesome. Atlantic Ocean's on the east side, and Pacific Ocean is on the west side by California, and Indian Ocean is up from there. Tropical storms are difficult for meteorologists to predict because they start in the ocean, which is much more difficult to monitor than the land. All right, next paragraph, next page, page 76. Other examples of extreme weathers include tornadoes, blizzards, flooding, and droughts. Tornadoes are a fast column of spinning air that stretches all the way from a cloud down to the Earth's ground with wind speeds of over 300 miles per hour. They can destroy most things in their path. They send us a warning for wind speed if it's 50 miles per hour and it blows the chairs off my deck and tries to blow my trampoline away, which it has before. And so imagine that's only about 50 miles per hour. So imagine 300. Pull the roof right off some houses like we saw in the video yesterday. Precipitation levels can also cause extreme weathers. In colder climates, blizzards can cause extreme damage as they bring icy cold weather with severe winds and high amounts of snow. When there is too much rainfall, flooding can occur. This is when the water levels rise into areas it shouldn't, like your backyard. Opposite to this, if the precipitation levels are too low, droughts could occur. This is when an area doesn't get any water for a long time. This causes lakes and rivers to dry up, affecting plant life and animals that live there, which is a problem for crops, as many of you know. If it's too dry, crops don't grow. If it's too wet, crops don't grow. These can be extreme temperature or extreme weathers, excuse me. All right, so you did your experiment, you did your reading. Now, after you have done these activities, I want you to see if you end up doing the experiment with the bottle, I want you to then answer these questions on this page just to help you think further into why tornadoes are the way they are. What happens when you spin the bottle clockwise? So I'm going to try that. I have it. I'm going to spin it of how the clock moves. So I'm going to spin it this way first. What happens when I spin it clockwise? So even if you don't do it, you could still answer these questions. All right. Oh, there's my tornado. Oh, I wish you could see it. Too much glitter, Mrs. Kodish. All right. So what happens when I spin the bottle clockwise? I see the water going that way as well. I can see it going that same way. So what happens when I turn it, when I spin it the opposite way? Don't watch my face when I do this. Okay, 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 okay. Oh, then the water spins that way. And there is a tornado on the inside. And again, I wish you could see that, but I used way too much glitter. What happens when you spin the bottle slowly? Okay, I'm going to wait for this glitter to calm down a little bit. You can write these answers according to what you saw or according to what you saw with me. So either way, when you did it or when I did it. So what happens when I spin it slowly? Okay. A few things move around, but you don't see that glitter coming back up where it's severe. Now, what happens when you spin the bottle quickly? Whew. Look at that. When you spin the bottle, number 5, does the tornado form quickly or slowly? I noticed it formed slowly. Okay, because it took me a lot of spins when you were watching my face go crazy. So it took a lot of spins. How does this activity help you understand how tornadoes work? So let's think about that. How does this help us to understand how tornadoes work? Think about that, and we'll talk about it tomorrow. Hopefully I wish we could talk back and forth of your thoughts, but I want you to be thinking about that for now. All right, this is all I want you to do today. And if you would like, you can do extra research on tornadoes, and I'll include a video if you want to watch that just for fun. Okay? All right, scientists, thanks for watching and have a great day.